Boeing's B-52 Stratofortress took to the skies 73 years ago, and the youngest examples still flying have been executing missions around the globe for over 6 decades. Now, despite its geriatric status, the U.S. Air Force is doubling down on the B-52, and in a very big way. This will come in the form of a slew of upgrades that will transform the Cold War-era bombers into truly 21st century weapon systems that will serve for decades to come, alongside the most advanced flying weapon mankind has ever built, the B-21 Raider. This is how the 8-engined bomber ended up in its current configuration, and a rundown on all the features and modifications that will transform today's B-52H into tomorrow's B-52J. Mention the name B-52, also known as the Buff, for big, ugly, fat fellow, and pretty much everyone knows about the smoke-billowing American jet bomber that stood alert at the height of the Cold War and featured heavily in the Vietnam War. In the post-Cold War era, the aircraft would take on a more prominent, precision conventional strike role, featuring new guided weapons and targeting systems so that it could play a key part in the global war on terror. Now, with the rise of near-peer competitors and a new dangerous age of so-called great power competition, the U.S. Air Force's future bomber plan includes a major overhaul of the force that will see the retirement of the swing-wing B-1 Lancer and America's first stealth bomber, B-2 Spirit. The all-new Northrop Grumman B-21 Raider will take over for these aircraft. For the foreseeable future, there will be no replacement for the nearly antique B-52s. That's right, the B-52 will outlive both of the Cold War bombers that originally succeeded it. But the Buff is showing its age, and to keep it flying and combat relevant as the Air Force's weapons truck of choice for decades to come will require some major upgrades. These will include long-awaited new engines, as well as a new radar and many other enhancements. This, revamped for the 21st century B-52, will stay in service until at least 2050, alongside the new B-21. Designed for transpolar nuclear warfare with the Soviet Union, the B-52 was Strategic Air Command's on-call nuclear weapons delivery service, with its crews orbiting high over the Arctic or sitting alert ready to launch in minutes during times of relative peace, and while teetering on the brink of nuclear Armageddon. As well as its nuclear role, the B-52 evolved as a conventional heavy bomber, with upgrades such as Big Belly that increased its capacity to carry conventional ordnance in its cavernous bomb bays to the tune of 84 500-pound or 42 750-pound bombs. The follow-on, Project South Bay, added an additional 24 750-pound bombs on underwing pylons. In Vietnam, high-flying B-52s rained down fire on the jungles below. The bomber's reputation found its way into popular culture, even with a drink and a pop group using the B-52's name. While born in an era of nuclear standoff, the B-52 proved its worth in conventional roles, responding to the demands of a changing security landscape. From bombing wide areas in Vietnam, and later Iraq, to launching waves of conventionally armed cruise missiles, to more recent conflicts where the B-52 could strike precisely with GPS and laser-guided weapons from high above. The latter occurred in the wake of 9/11, when B-52s fought in Afghanistan, taking on the new mission of providing precision close air support to troops in contact. B-52 crews would hone this capability over the years, employing it continuously over 2 decades of counterinsurgency and counter-terror operations. Today, the Buff remains a key component of America's nuclear deterrent and conventional long-range strike capabilities. But the jet's cocktail of new features, some of them decades in the making, is not only likely to push it close to or even beyond the century of service mark, it will also create a Stratofortress like we've never seen before, one customized to confront a slew of modern threats, and especially China. The end of the Cold War saw a drastic cut in the B-52 force, in terms of numbers. All of the early models were long gone, with huge numbers of Buffs lying forlorn in desert storage in Arizona, with their wings unceremoniously lying next to their abandoned fuselages to comply with the new Strategic Arms Reduction Treaty with Russia. The only Stratofortress variant that still remains in service today is the B-52H, which is a derivative of the B-52G, with Pratt & Whitney TF-33 low-bypass turbofan engines. Deliveries of the H began in May 1961, and with 102 constructed, it took the final tally of B-52s built to 744 aircraft. Until the end of the Cold War, the B-52H model was committed almost exclusively to the nuclear role. Beginning with the conventional enhancement modification in 1994, it had its non-nuclear weapons options increased, ultimately adding to the precision-guided bombs mentioned earlier. The B-52H variant first went to war in September 1996, when the type launched AGM-86 conventional air-launched cruise missiles, or CALCMs, against Iraqi targets. That began a long-running campaign of combat operations in both the Middle East and Afghanistan. Strapped with a targeting pod, this is when the B-52H took up the close air support role, which couldn't have been more different from the airborne nuclear alert mission in which the type had begun its service. Now, the H model is getting a new designation to account for all the upgrades that are headed its way, the B-52J. Here's exactly what will transform H models into Js. The U.S. Air Force has, for decades, tried to replace the power plants on its roughly 72 remaining B-52s. Even the fuel-hungry TF-33 engines on the youngest H variants went out of production in the 1980s, and the Air Force has had to develop its own specific maintenance shop at Tinker Air Force Base in Oklahoma to keep them going. With no ready supply of new spare parts, the costs associated with both routine and more serious maintenance have grown dramatically over the years. Proposals for re-engining B-52Hs and earlier variants with older engines date back all the way to the 1960s. The size of the bombers, and specifically the clearance under the inboard wing area, also made them attractive test beds for new engine designs. At least one B-52 assisted General Electric in the flight test of its TF-39 and CF-6 high-bypass turbofan engines. Pratt & Whitney also flew the JT-9D on the B-52. In terms of actual new engine options for B-52s, during the 1960s and 1970s, Boeing proposed replacing the 8 engines on H and G models with 4 larger and more efficient high-bypass turbofans. During the same period, the company also pitched the idea of substituting the 4 engine pods on these bombers with a pair of more powerful engines in a single pod under each wing. The Air Force passed on both concepts, in part due to focus at the time on development of the new B-1 bomber. Between the 1980s and early 2000s, Boeing and Pratt & Whitney both proposed several additional re-engining concepts, involving the replacement of the 8 TF-33s with 4 newer engines, such as the PW2000, also known as the F-117, which is found on the C-17 Globemaster III, as well as the CF-6, which equips some 747s, and now the upgraded C-5M Galaxy, among a number of other types. Boeing assessed that it could cost as much as $4.5 billion to give the remaining B-52Hs new engines, but that the Air Force would save more than that, thanks to improved fuel efficiency and other benefits across the rest of the life cycle of the jets. A Defense Science Board report published in 2003 came to similar conclusions, projecting initial costs of between $3 and $3.5 billion for a re-engining effort, depending on the exact engine chosen, but savings of between $9 and $12 billion. In 2014, the Air Force again studied what it would need out of a re-engining program for the B-52. It came to the conclusion that new power plants would need to save between 10 and 25% in fuel consumption, and would have to go 15 to 25 years before the first invasive overhauls of the engine are required. Still, the nagging question remained over whether 4 large engines or 8 smaller ones, or even a 6-engine arrangement, would be the best solution. One area of concern was whether relocated engine pylons would be needed to accommodate new power plants mounted under the Buff's drooped wings. Such a requirement would potentially result in a costly re-engineering of the B-52's wings. With 4 larger engines, such as the General Electric CF-6 or engines similar in size to the Pratt & Whitney PW2000, rudder authority for engine-out operations also was a concern. Then there was the issue of ground clearance for much larger turbofans. As a result, costly structural and flight control upgrades may have been needed to accommodate their use. By the late 2010s, the Air Force had made the key decision to continue flying B-52Hs out to at least 2040, which has since been extended out even further to 2050. This finally made re-engining the Buff a high priority. In 2017, Boeing put out a video with a new public pitch for a complete re-engining of the remaining B-52Hs, arguing that in doing so would save more than $10 billion between then and 2050. Beyond cost savings, the company estimated that the increased fuel efficiency from new engines would give the bombers up to 40% more flying time per sortie. Boeing also asserted that the replacement engines were unlikely to ever need to be overhauled before the bomber's final retirement date. The increased range, thanks to fuel-efficient engines, would open up new operational possibilities and lower Buff's dependence on an aging aerial refueling tanker fleet. Improved field performance was another advantage of these new engines. The jet's visual signature would also be reduced, with the long smoke trails it was so well known for no longer being an issue with modern engines. The Air Force finally determined the best option was a straight swap of the 8 TF-33s for 8 compact high-bypass turbofans fitted to the aircraft's existing pylons and recontoured dual nacelle pods. The hope was that this would not only offer savings in terms of cost, but also in time, thanks to a faster engine integration and flight test schedule. Overall, 8 new engines were seen as the least risky option. In 2021, after more than 50 years of re-engining proposals, the Air Force finally moved ahead with plans for a one-to-one swap of the existing engines on each of its B-52Hs. The Rolls-Royce F-130, a derivative of the BR-700 engines that power some Gulfstream and Global Express business jets, beat out General Electric's CF-34-10 and Pratt & Whitney's PW-800 to replace TF-33s under the Commercial Engine Replacement Program, or CERP. CERP has run into major cost growth, but just how much remains unclear. Still, with the Air Force betting its future bomber force structure on the B-21 and B-52, the re-engining program has got to work, and major delays could have significant cascading impacts. Regardless, with the Air Force moving ahead with CERP, once the re-engined buff becomes a reality, it will be officially designated as the B-52J. Boeing is overseeing the engine integration and the aircraft's overall modernization program. The new larger engine nacelles to house the F-130 engines will be supplied by Spirit Aerosystems. Their larger diameter means that they need to be positioned closer to the wing than their predecessors in order to fit properly. The first 2 test B-52s will be modified at Boeing's San Antonio, Texas facility beginning in 2026, and ground and flight tests are planned to run from 2028 until 2031. A massive new hangar is also being built at Tinker Air Force Base to support the exhaustive upgrade project, with the new building able to house up to 4 B-52s at a time. An artist rendering from Boeing, released in October 2022, depicted the B-52J as it could look in its future fully upgraded form, which notably includes a reprofiled nose. This new nose section will contain a version of the AN/APG-79 Active Electronically Scanned Array, or AESA radar, which is scheduled to come into service around the same time as the new engines. This radar is a version of the highly proven system installed in the Navy's FA-18EF Super Hornet, EA-18G Growler, and the remaining FA-18 Legacy Hornets flying with the Marine Corps. The AN/APG-79 will give the B-52 greatly improved radar range, fidelity, countermeasure resistance, situational awareness, and other capabilities. The radar could even support advanced electronic warfare and long-range communication functions. This is a true multi-role, multi-mode system, and it will even give the B-52 air-to-air surveillance and tracking abilities for enhanced situational awareness and even potentially self-defense. With the ability to detect and track moving targets on the ground and at sea, it can be used to guide networked weapons directly onto those targets over long distances. The aircraft's targeting pod can be slaved to what the radar is seeing and vice versa, which will help with visual target acquisition and identification, including of aircraft over long distances. Even for general reconnaissance and intelligence gathering, the B-52's long loitering time and payload flexibility will pair extremely well with the new radar. Also in the rendering, a pair of fittings under the nose have been eliminated entirely. First added to the B-52G and B-52H variants in the 1970s, the 2 enclosures together formed the AN/ASQ-151 electro-optical viewing system, with the right one holding a Hughes AN/AAQ-6 forward-looking infrared system, and the left one containing a Westinghouse AN/AVQ-22 low-light level television system. The EVS's main purpose was to help crews fly safely at low altitudes, so that they could penetrate deep into enemy airspace in any weather, day or night, and with flash curtains drawn for nuclear strikes. But they also had secondary, albeit very limited, surveillance capabilities. The EVS on the Air Force's remaining B-52Hs has already been supplanted, at least in some ways, by modern targeting pods, either Lockheed Martin Sniper or Northrop Grumman Lightning types, installed on pylons under the bomber's right wing. Also, its low-level penetration mission has withered over the post-Cold War years. Today, the B-52 relies on long-range AGM-86B cruise missiles for its nuclear deterrence mission, and isn't even cleared to drop nuclear bombs in combat. The new radar, plus the elimination of the EVS fairings, could result in the major reprofiling of the B-52's notoriously lumpy nose, as seen in the concept art, which could lower drag and improve efficiency further. Two humps atop the fuselage, which also appeared in the artist's impression, are representative of enhanced satellite communication systems destined for the upgraded B-52. B-52s are to receive improved GPS systems and Link 16 data links, as well as new low-frequency, very low-frequency, and advanced extreme high-frequency communication suites. The bombers are already receiving upgraded satellite communications, allowing them to exchange information around the globe like never before. These updates will allow the B-52J to communicate and integrate with disparate platforms across an intricately networked future battle space. As a result, the future buff can act as an advanced weapons truck, even striking targets over great distances that it can't detect with its own sensors, on the request of other platforms operating far forward from its position. Targeting and threat data piped to it from space-based systems, including massive distributed constellations that constantly track targets across huge geographic areas, will also unlock the future buff's potential. A much-needed cockpit upgrade is also underway. The biggest change will be the replacement of the iconic array of steam gauge dials in the center panel, with a pair of large digital multifunction displays. Smaller multifunction displays have already replaced existing monochrome monitors that sit in front of the pilot and co-pilot. The rest of the buff's crew will also get similar digital interface upgrades. In addition, there are plans to integrate a new advanced electronic warfare suite onto the B-52 to improve its ability to sense threats over long distances and defend itself from attack. L3 Harris has been contracted to provide this new system that can simultaneously counter multiple electronic spectrum threats without interfering with the aircraft's operations. The AN/APG-79 radar is likely to be deeply integrated into this new system. The Air Force plans to add a variety of new weapons to the buff's arsenal. The vision for the B-52 as a standoff weapons truck that seamlessly shares data with other platforms in the battle space will be heavily reliant on this new array of munitions. Chief among the new arrows in the B-52's quiver are hypersonic weapons, for which the Stratofortress has been singled out as an ideal launch platform. A combination of speed and maneuverability make these weapons highly effective in penetrating dense air defenses to prosecute time-sensitive and very high-priority targets. Consequently, the B-52's hypersonic weapons launch capability will be key in breaking down the enemy's metaphorical door, so that other platforms, including stealthy ones, can survive within striking distance. In March of 2024, a B-52 flying from Andersen Air Force Base on Guam launched a live AGM-183A air-launched rapid response weapon, better known as Arrow, during a test over the Pacific. In addition to being a major show of force in the region, this was also the last planned Arrow flight test. Arrow's two main components are a rocket booster and an unpowered hypersonic boost glide vehicle. The missile uses its rocket booster to get to a high speed and altitude before releasing its boost glide vehicle, and then follows a relatively shallow gliding trajectory within the atmosphere to its target, maneuvering erratically along the way. That maneuverability, plus its hypersonic speed, defined as anything above Mach 5, make weapons like this extremely hard to defend against. Arrow's future is now murky, but it's possible that a follow-on effort could be already underway in the classified realm. Meanwhile, a Raytheon and Northrop Grumman-led team is developing another hypersonic weapon under the Hypersonic Attack Cruise Missile program, known as HACM. Unlike Arrow's boost glide propulsion method, HACM uses an air-breathing engine to sustain its high speeds. Air Force Global Strike Command's B-52s are set to be one of the primary launch platforms for these missiles when they begin entering service, which could come as early as 2027. When it comes to HACM, the Air Force says the B-52s will need new underwing pylons to be able to carry the full desired load of these weapons. The service says the improved common pylons that B-52s have used for decades to carry various conventional weapons under their wings, which are only rated for munitions in the 5,000-pound weight class or below, will not be up to the task. In 2018, the Air Force had announced its interest in acquiring new underwing pylons for the B-52, specifically to accommodate munitions weighing up to 20,000 pounds. These pylons, which Boeing dubbed Hercules, look to be related to the development of Arrow, but could also be used with HACM and other outsized payloads. Thanks to other past upgrades, B-52s can carry a wide variety of conventional munitions, cruise missile-like electronic warfare-equipped decoys, and even leaflet bombs, as well as nuclear-tipped AGM-86Bs on new smart rotary launchers in their bomb bays and on their underwing pylons. Before the smart rotary launcher upgrade, modern guided weapons could not be carried internally, as the munitions could not communicate with the B-52's combat systems. So these new launchers drastically expand the buff's payload flexibility. The non-nuclear weapons the bombers can now carry include various precision-guided bombs, winged naval mines, and the AGM-158 Joint Air-to-Surface Standoff Missile, or JASSM series, of stealthy cruise missiles. In November of 2019, the service notably retired the conventional variants of the air-launched cruise missile, the AGM-86C and D versions, leaving JASSM and the subvariants as the only conventional standoff land attack missiles certified for use on the B-52. The bombers can also employ AGM-84 Harpoon anti-ship missiles. The JASSM family, including a possible version with a 1,000-mile range called the JASSM Extreme Range, or JASSM XR, is likely to be the primary conventional standoff weapon for America's bombers for the foreseeable future. Congress has eliminated a requirement for a conventional version of the future AGM-181A Long-Range Standoff, or LRSO cruise missile, the nuclear-armed version of which is still slated to replace the AGM-86B air-launched cruise missile. The secretive LRSO, which Raytheon is developing, will be highly survivable, including having a very stealthy airframe, and it's possible that its range may be significantly greater than its predecessor. The ability to communicate with the launch platform and other command and control assets, and the ability to sense threats in its environment and avoid them, are also possible features, as they already exist on advanced conventionally armed cruise missiles. The U.S. Air Force has conducted at least 9 flight tests of prototypes of its nuclear-tipped LRSO. This includes a test where a prototype missile successfully flew by itself along a set route while loaded with a special test article designed to act as a surrogate for a W-80-4 nuclear warhead. All of this puts the Air Force ever closer to fielding LRSO, which will act as the B-52's primary strategic weapon. The LRSO is also set to arm the B-21 Raider, and is part of the broader long-range strike family of systems that also includes the Raider, along with a classified array of other aerial platforms, sensors, communications architectures, and weapons. New weapons that will find themselves on the buff will be increasingly networked, with the ability to work together autonomously as part of cooperative swarms. Considering the raft of weapons in development for the B-52 and its stablemate B-21, its development story will not end there. The baked-in versatility of the B-52, along with its new engines, digital infrastructure, upgraded radar, and vast payload carriage options and capacity, mean it will be able to accommodate many next-gen weapons, including very large ones no other aircraft in the inventory can lug around. Carrying and deploying drones is also on the horizon. This could include air-launched effects, small unmanned aircraft that can be deployed mid-air to conduct a host of missions in heavily defended territory, as well as much larger high-performance unmanned combat air vehicles that can carry weapons far forward into highly contested airspace. The latter could even be commanded by the Buff's crew, defending the aircraft from enemy threats emanating far deeper into hostile territory than the B-52 could survive. With its new radar and situational awareness enhancing abilities, the Buff could also don its own air-to-air missiles, not just for self-defense, but to act as an arsenal ship, lobbing very long-range effectors on the demand of fighters and other platforms operating in the thick of the fight far ahead of them. Finally, new podded systems could bring advanced networking and sensor systems to the Buff. They can be bolted on and off as needed, potentially offering advanced and highly tailored standoff surveillance, network connectivity, and standoff electronic warfare support for joint forces. Lasers could also end up on the Stratofortress, which is amazing to ponder, considering it first flew in the dawn of the jet age. These directed energy systems can work in a self-defense capacity, swatting down incoming missiles, and even burning holes in approaching aircraft. This kind of extreme adaptability has helped ensure that the B-52 has remained a priority for Air Force decision-makers, even over 60 years after the last ones rolled off the production line. Now the Air Force's oldest kinetic platform, still in service, is set to serve alongside its newest as a uniquely diverse but complementary strategic air power team. No matter how confident Boeing's engineers were in their creation when it took to the skies so long ago, they would have never imagined the Stratofortress would remain in the fight through the middle of the next century, as a high-tech multi-role platform with a career spanning nearly 100 years. It may sound cliché, but just like a fine wine, the B-52 seems to just get better with age.